Alright, thank you, Sam. And as you can see here, I have this very same speaker over here on my desktop, open in SpaceClaim. You can see the actual driving dimension that Sam has set up in the model. And now I'm going to switch over to COMSOL, where I have started a new model. And in this case, I'm going to add just one geometry operation to the geometry sequence in COMSOL, which is going to be the live link interface to SpaceClaim. And as soon as I click the synchronize button, all the parts of this geometry are transferred over to COMSOL. Now, of course, the interesting part here is to show how you can drive the geometry from your COMSOL model. And it's just simple as actually entering the name of this driving dimension that has been set up in SpaceClaim. And I enter a new value for it, for example 20, so I'm going to go from 9mm to 20, and then I just hit synchronize again. As you can see, the geometry has changed, and if you go back to SpaceClaim, you can see that the value has been changed there as well. Now, of course, the beauty of this is that you can do this automatically, and just as you have the parameter, the driving dimension in SpaceClaim, the COMSOL model also can have driving dimensions called global parameters. And if I want to do this automatically, then instead of a value, I enter a name of a parameter that I will define in COMSOL. And here I just call it position. Now, if I click somewhere, you can see that it's red, and it means that I haven't defined it yet. But I'll just do it here under global definitions. So here it's where I can enter my name, position, and I'm going to just move it back to where it was. I'm going to set it to 9. And now when I synchronize, the position of this tweeter will change back. Now, when you want to set up a simulation, which I'm not going to do it this time, but you would actually solve this problem, so you would add a parametric sweep under your study node, which includes all the Soros settings. And if I do that, I can drive the simulation based on the parameters that I have defined. So I'm going to use it based on position. I choose it from the list of available parameters. And I could actually add several other parameters to this list. And then I just have to define a range for this parameter. So I could start at 9 and probably stop at 20, and I could do it in steps of 1. So now if I would choose compute, if I would have set up the simulation with all the physics and everything, then it would sweep over the range of 9 to 20 for the tweeter position. And in fact, I have done that before. So I have a model here which I've actually solved for a number of values, and here this plot is actually showing the sound level around the speaker. And if I it's just on a slice through this 3D air volume. So even though the solution is in the entire 3D, to illustrate it, I'm showing just a slice through it. And you can see how the sound pressure actually is changing around the speaker for the various positions of the tweeter. Now, just to round off, I can show you that in this model, I've actually, you see a green surface here in this plot. So I've added some extra steps in my definition of the model just to produce this surface, which would correspond to a hard surface of the speaker enclosure. So it's perfectly okay to use the live link interface and transfer something from SpaceClaim, and at the same time create geometry operations as well in COMSOL multiphysics. So the live link interface makes sure that everything stays associative, not only if you just transfer something, but also if you would add any other geometry steps to it.